Good afternoon, students. The next problem which we are going to discuss is plane stress with thickness problem. If the plane stress, in the sense, if there is no stresses varying in the z direction, generally in any of the direction, is an example for plane stress. If it is negligible or not varying, is a plane stress problem. For example, a plate with a wall is a standard example for a plane stress problem. Generally, in this type of problem, we are finding we are evaluating the maximum stresses. We know the stress concentration factor for the given dimension from the data and book, and we find the maximum stress induced in the plate. So the stress concentration factor Kt is given by sigma max by sigma nominal. Sigma max is we have to evaluate. Kt we can know from the data and book, design data and book. Sigma nominal is given by load divided by sigma nominal or sigma average is given by load 4000 Newton divided by W into D minus T. That is the least area cross section. W minus D into T. W is 40 minus D is 10 into thickness is 5 mm. W minus D into T. So we can evaluate. We know the stress concentration factor. We know the average and minimum area of minimum stress, and then we can evaluate the maximum stress. Okay, this is the theory behind this problem. Let us go and solve the problem using the software. I will clear and start the new file. Okay, do not read the file. Preferences, structural problem. Okay, preprocessor, element type, add element, add. Since it is a 2D problem, I will select the element as solid quad element. There are two types of 2D elements, either there are higher order elements also. Generally, it's either quad or triangular element. Quad 4 noded 182. Say OK. Also, one should note that since there is a thickness of 5 mm, if it is not specified in the problem, generally thickness is assumed as 1 mm. Since it is given, you should mention as plane stress with thickness. Say OK. Close. Real constant, add. Thickness is the real constant. Give 5 mm. Say OK. Material properties, material models, structural, linear, elastic, isotropic. The Young's modulus is 210 GPa, 210 e power 9, and the Poisson's ratio is given in the problem as 0.3. Say OK. Modeling, create. We need to create the areas, rectangle by dimension. The x coordinate is 0. The y coordinate, the x dimension, I need to define the width and the height. X1, x2, it's 60 and 0 and 40. The rectangle is created. We need to define a circle by solid circle. It has to be at the center. I will define the center as the x coordinate is 30, the y coordinate is 20, 30 and 20, and the radius of the circle is 5 mm. Say OK. The circle is created. Plot, multiply. Now we need to create a hole. For that we need to go to booleans, operate booleans. Whatever you want to delete, for example in this case I want to delete this hole. It has to be selected. Let me explain this first. I need to select subtract areas. Select this area. There are two areas we have created. The first area was the rectangle and the second area is the circle. So let me select the first area. The picked area is 1. Say OK. You need to say apply. Next, select this area. There are two areas. Picked area is 1. We need to select the second area. Say second area. Say OK. Say OK. Automatically the hole has been created. Okay. Also, one should be conscious that they can also see the thickness style, size and shape. Sets on. This should be seen like this. Thickness. There is a thickness we have given. Once the element will be created, I think the thickness will be there. Meshing, mesh tool, smart size, this if you go if you increase the number, the mesh will become coarse. If you decrease the number, mesh will become finer. I will take it as 2. Since we are meshing the area set, say OK. Element edge length, let me define, let it be 2 mm, say OK. Hide and raise and hide button, mesh, once and select, say OK. Mesh automatically created. Okay. Now this is a load of 4000 Newton applied. Now we have to go to boundary condition, loads, define loads, structural, displacement, on lines, select this line, say OK. It is fixed in all degrees of freedom. Since the quad element, 2D element, it can translate in x direction and y direction only, the 2 degrees of freedom, say OK. And while applying the load 4000 Newton, we should convert this into pressure and apply it on lines. So I will be converting it into 4000 divided by the width into length, 40 into 60, 4000 divided by 40 into 60. No, this is not proper. You may hold on. Sorry, hold on. That what you have to take is 4000 divided by 40 into the thickness 5 mm. So it will be, hold on, sorry, the 4000 divided by 40 into 5, it's around 20 MPa. This 20 MPa. Okay, we'll go back to the problem. Structural, apply force or moment, pressure on lines, 20 MPa pressure has to apply on this line, 20. Since it is acting away from the body, a negative direction 20 MPa, minus 20 has to be given. So it will act away from the body, minus 20 MPa. Okay, this will act away from the body. Next, solution, solve current load step, say OK. Solution is done. You can view the results, result processor, plot results, contour plot, element solution. Okay, the maximum stress is 64.0927 MPa. This is theoretically we find the same. This is around this region, 64 MPa. We are getting it. You can also see the deformation, plot controls, animate, deform shape, deform plus undeform. This is how the plane stress. This is a plate with all deforms under the applied load. Generally, in case of theory of elasticity, the stress concentration should be 3. The standard, the actual, the practical, the theoretical value should be 3. But depending upon this width and the other dimension, W by D, we will get the stress concentration. But for a given for a hole, the stress concentration KT is going to be 3 from theory of elasticity. I'll close this for you to view 3-dimensionally, plot controls, style, size and shape. Switch on this. Okay, plot, multi-plot. So we can see the thickness 5 mm in the z direction. This is about your first problem. You plate with a hole problem. You can see the element solution. There are many elements. So the maximum stress in each element it will indicate here. So many elements are created here. You can see a finite number of 64 MPa is the maximum stress. Okay, this is about your plate with a hole problem. Thank you.